Dear students, today I am going to explain the molecular orbital diagram of carbon monoxide and electronic configuration of molecule. In the previous classes, we have learnt the electronic configuration of atoms. Now we are going to understand how to write electronic configuration of a molecule. Carbon monoxide is a molecule and the magnetic properties of carbon monoxide. So first, carbon monoxide, CO. In this molecule, carbon is one atom. The atomic number of carbon Z is equal to 6. So the electronic configuration of carbon is 1s2, 2s2, 2p2, and oxygen, atomic number of oxygen Z is equal to 8. The electronic configuration of oxygen is 1s2, 2s2, 2p4. So we have carbon and oxygen. The atomic orbitals combine together to form molecular orbitals. Now take 2p2 from carbon, 2p2, p orbitals are 3. So therefore, these 3 boxes represent p orbitals, 2p2. According to Hund's rule, we distribute 2 electrons, 1 and here 1, 2p2. Similarly, the oxygen atomic orbitals of p orbitals of oxygen, so 3 p orbitals, 2p4. According to Hund's rule, I distributed these 4 electrons like this, one by one first, then I pair the electrons in first orbital. These are atomic orbitals. Now I want to show you the molecular orbitals. The first molecular orbital. This is the molecular orbital. 2 molecular orbitals, and this is 1 molecular orbital, and again 2 molecular orbitals with same energy, and finally 1 molecular orbital. These are the molecular orbitals. The names of molecular orbitals are very important. Let me write the names of these molecular orbitals. Pi 2px, pi 2px. The name of this orbital is pi 2py, and this is sigma 2pz. Sigma 2pz has slightly more energy than pi 2px, pi 2py. Then these orbitals pi 2px star, and this one is pi 2py star, anti-bonding orbitals we call, and the last one is sigma 2pz star. These are the molecular orbitals. Here we have 2 plus 4, 6 electrons. Now distribute the 6 electrons in molecular orbitals with the use of Hund's rule and Aufbau principle and Pauli's exclusion principle. So here 2 orbitals with same energy, so we distribute 1 electron each first, then pair up 1 electron for this one and another electron, then again I will pair up this orbital, 2 electrons in this orbital. So we have 6 electrons, 4 electrons already filled up, 2 electrons, remaining 2 electrons, I put these 2 electrons into sigma 2pz. Now this diagram is completed, we call molecular orbital diagram. So here regarding to 2p2 and 2p4, I complete this diagram. Next 2s2, 2s2. How these atomic orbitals combine together to form molecular orbital? Let me show. Here, this is one of the 2s2 from carbon. S orbital is only one, and this one also 2s2 from oxygen. So S orbital only one box and it contains 2 electrons. So I will show you the electrons in like this. Then these 2 atomic orbitals combine together to form 2 molecular orbitals. This is one molecular orbital, this one, and another molecular orbital. 2 molecular orbitals. Number of atomic orbitals is equal to number of molecular orbitals. Now we have 4 electrons, distributed 4 electrons in this molecular orbitals. I give 2 electrons for this one and 2 electrons for this one. The name of this orbital is sigma 2s, and this one is sigma 2s star. So here it is a bonding orbital. This sigma 2s star is anti-bonding orbital, because anti-bonding orbitals has more energy than bonding orbitals. Now we have completed 2p2 combination of p orbitals and combination of 2s orbitals. Now we have 1s2. Here oxygen 1s2. Let me show you how 1s orbitals combine together. Here 1s2 from carbon atom, 1s2, and 1s2 from oxygen. 2 electrons are present at 1s2 orbital. Here also 2 electrons. These 2 are atomic orbitals. If these 2 atomic orbitals combine together to form molecular orbitals, how many molecular orbitals? 2 molecular orbitals. This is 1 and 2. The name of this molecular orbital is sigma 2s, and this one is sigma 2s star. Whenever without star, this orbital is called bonding orbital, less energy. With star, this orbital is called anti-bonding orbital, high energy than bonding orbitals. Now distribute the electrons in these 2 orbits. We have orbitals. These 2 electrons, I will give this one for 2 electrons for this orbital. So now we completed the molecular orbital diagrams of carbon monoxide. So first we starts with p orbitals and ends with 1s orbital. Now at the end of this diagram, I will note it down. It is atomic orbital. On the left side of these diagrams, atomic orbitals. So these orbitals comes from atoms, and this one also atomic orbitals. So what is important in these diagrams? Molecular orbitals. So the middle part of the diagrams, molecular orbitals. We note down molecular orbitals. Atomic orbitals combined together to form equal number of molecular orbitals. So the distribution of electrons is taken in molecular orbital according to the laws of electronic configuration. Now we have to write the electronic configuration of carbon monoxide. Electronic configuration. Electronic configuration of carbon monoxide. How to write? If you complete the molecular orbital diagrams, it will be very easy to write electronic configuration. We starts with sigma 2s, very least energy. Sigma 2s, 2 electrons are present, sigma 2s2, and sigma 2s star 2. Now write electronic configuration like this. The first one is sigma 1s, not 2s, sigma 1s. Sigma 1s. This one is sigma 1s star, not 2s. So therefore sigma 1s, sigma 1s, sigma 1s 2, sigma 1s star 2, sigma 2s2, sigma 2s star 2. Look at the diagrams and write sigma 2s2, sigma 2s star 2, and this one is very important. Pi 2px2 is equal to pi 2py2, both are same energy, and sigma 2pz2. So therefore complete the electronic configuration of carbon monoxide. Pi 2px2 is equal to pi 2py2, both are have same energy, so we write like this, and sigma 2pz2. This is the electronic configuration of carbon monoxide. Now we have to find the bond order. Bond order. Bond order is equal to half into NB minus NA. Half into NB minus NA. So that is equal to NB, number of bonding electrons. So the electrons present in without star we called bonding electrons. So here 1s2, these two electrons are called bonding electrons. The electrons present in bonded orbitals we call bonding electrons. So NB means bonding electrons, Na means anti-bonding electrons. How many electrons are present? 2, 4, 6, 8, 10. 10 bonding electrons are there. The electrons are present at anti-bonding orbitals are called Na. 2, 4, 4, only 4 divided by 2, that is equal to 10 minus 4, 6 by 2, that is equal to 3. So bond order is 3. The number of bonds present between carbon and oxygen is 3. So therefore there is a triple bond. There is a triple bond present in CO. CO means carbon monoxide. How can you denote that triple bond? C triple bond O. Bond order means number of bonds present in a molecule. Now I want to write the magnetic property. Magnetic property. So what is the magnetic property of carbon monoxide? If you look at the diagrams of molecular energy diagrams, here two electrons, pair of electrons, and you can observe all electrons in molecular orbitals are paired, no unpaired electrons. If any molecule doesn't have unpaired electrons, it is diamagnetic in nature. So similar to the nitrogen, carbon monoxide also, there is no unpaired electrons. There is no unpaired electrons. So carbon monoxide is diamagnetic. So that is the magnetic nature of carbon monoxide.